Dear children, welcome to this session on Chapter 14, Classes and Objects in C++. C++ is an object-oriented programming language. Classes and objects are the key features of object-oriented programming. Class is a user-defined data type. Look at the classification of data types in C++. Class comes under user-defined type. Hence, class is a user-defined data type. Next, let us see the general form of class declaration. To declare a class, first you have to write the keyword class followed by class name, and then the body of the class ended with semicolon. Here, class is the keyword to be used to declare a class. Within the body of the class, there can be three labels: private colon, protected colon, public colon. These three keywords, private, protected, public, are called access specifiers. Under each of the access specifiers, there can be variable declaration and function declaration. But how do these access specifiers, private, protected, and public, differ? The variables and functions declared under private can be accessed only within the class. The variables and functions declared under protected can be accessed within the class and also in the inherited class. The variables and functions declared under public can be accessed from outside the class also. All the variable declarations and function declarations are called members of the class. Therefore, a class comprises of members. The variable declarations are together called data members, and the function declarations are called member functions. A class comprises of members, and members are further classified into data members and member functions. The data members are the data variables that represent the features or properties of a class. Data members are also called as attributes. Member functions are the functions that perform specific tasks in a class. Member functions are also called as methods. Using this syntax of class declaration, let us now write an example. Class box followed by body of the class and then ended with semicolon. Class is the keyword to be used and box is the class name. Within the body of the class, I am going to have members under private, protected, and public access specifiers. Under private, I am declaring 4 integer variables: length, breadth, height, and wall. Under protected, there is going to be 2 member functions, accept and calculate. And under public, 1 member function called display. Now, box is a user-defined data type. I can create objects from this class box by writing box b1 semicolon. Here box is the class name and b1 is the object. What will be the memory allocation for object b1? For each object, memory is allocated only for the data members of the class. The data members of this class box are length, breadth, height, and wall. So the object b1 also has memory allocation for the data members length, breadth, height, and wall. Since each of these data members are of int type, each of them are allocated 4 bytes of memory. So the total memory allocation for the object b1 is 16 bytes. Here in this statement, box b1, an object of the class is created. This process is called instantiation. The process of creating an object of a class is called instantiation. Instead of writing a separate statement for creating the object, I can create the object by placing it just after the curly bracket but before the semicolon. There are three access specifiers: private, protected, public. But private is the default access specifier. So if I do not mention the access specifier private, the members without an access specifier are automatically considered to be private. Now let us see the main function of this example. In this statement b1.display, b1 is the object, dot is the dot operator, and display is the member function. Therefore, to access a member of the class, you have to do so by using the name of the object followed by the dot operator, object dot member. Also notice that here I have accessed only the display member function of class box. I didn't write b1.accept or b1.calculate. This is because accept and calculate are under protected access specifier. What is the meaning of protected? The members under protected can be accessed only within the class and in the inherited class. That is, these members cannot be accessed in the main function. Only the display member function can be accessed under main because display is coming under public. Public means the members can be accessed from outside the class also. Next, let us see the differences between class and structure. The data members of a structure are by default public. That is, within a structure, when an access specifier is not mentioned, the members are automatically considered to be public, whereas the data members of a class are by default private. That is, in a class, when an access specifier is omitted, those members are treated as private. Here in this main function, I am able to access the members of this structure student by writing s1.roll number, s1.height and s1.weight, because these members, roll number, height and weight, are by default public, and you know that public members can be accessed from outside the class also. That is why I am able to access them in the main function. But here in this class box, I cannot access the private members length, breadth, height and wall in the main function because private members are accessible only within the class, which means they cannot be accessed outside the class. These three initializations can be combined into one like this. That is, the object of a structure can be initialized at the time of declaration, but the object of a class cannot be initialized at the time of declaration. These are the differences between class and structure. In this class declaration, I have given only the prototypes of the member functions. But during actual programming, you have to write the function definitions for these prototypes. So, I will show you how to define the accept function. Remove the semicolon of this prototype and then write the body of the function within curly brackets. Since I have defined the accept function within the class itself, this function definition is called inline function. I can also define a function outside the class. For example, to define the calculate function outside the class, you have to follow this method. In the function header, in front of the function name, you have to insert the class name and scope operator. Box is the class name and double colon is called scope operator. So in front of the function name, that is in front of calculate, you have to write box double colon. That is the class name followed by scope operator. The class name and scope operator together is called as membership label. Scope operator is also called scope resolution operator. And then you complete this function definition by writing the statements within its body. When you define a function outside the class, it is called as an outline function. That is when you mention only the prototype of the member function inside the class, but you write the definition of that function outside the class, it is an outline function definition. An object of a class cannot be initialized at the time of declaration. But if we wish to initialize the object at the time of declaration, we have to define a special member function called constructor. Constructor is a special member function to create and initialize an object. I will remove the accept function because I am going to write a constructor inside this class which will initialize the object. Before you begin to write a constructor, you should know some points about constructor. Constructor has same name as the class name. Constructor has no return type. Constructor has same name as the class name. The name of my class is box. So here I write box and parenthesis. Since the constructor has no return type, in front of this function name, you should not mention any return type. Just write the name of the class and parenthesis and then the body of the constructor. And within this body, you can initialize the object by giving values for length, breadth and height. A constructor is executed automatically when object is created. I am creating an object of this class box in the main function box B1. Constructor is executed automatically when object is created. That is, at the moment the object B1 is created, the constructor gets executed automatically. So this constructor gets executed automatically and the object B1 is initialized with the values given in this constructor. Length is 40, breadth is 20 and height is 15 and wall gets the default value 0. Also note that the constructor is defined under public access specifier. This allows us to create objects in any function. Now suppose I declare two objects B1, B2. In this statement, when the first object B1 is created, immediately the constructor gets executed and B1 is initialized. And when the second object B2 is created, once again the constructor gets executed and B2 is initialized. So every time you declare an object, each time the constructor gets executed. Observe the two objects B1 and B2. They are initialized with the same values. This is because the same constructor gets executed every time you declare an object. But we want objects to be initialized with different values. The constructor which I have defined here is a non-parameterized constructor. That is a constructor without parameters. A constructor without parameters is called as non-parameterized constructor. It is also called as the default constructor. Now look at this constructor. It has parameters. It is a parameterized constructor. Int L, int B, int H are the parameters. So the data members length, breadth and height must be now initialized with the parameters L, B and H. When you define a parameterized constructor, then while declaring objects itself, you can pass values to this constructor like this. Box B1 and within parentheses 40, 20, 15. When this object B1 is created, and since B1 is supplied with 3 values, the parameterized constructor, which has 3 parameters, is executed. The values 40, 20 and 15 are passed to L, B and H, and these values then get initialized to the data members length, breadth and height. So the object B1 is created as shown here. Length is 40, breadth is 20, height is 15 and wall gets the default value 0. And similarly, when the second object B2 is created, the constructor gets executed and the values 30, 50 and 18 are passed to the parameters in the constructor L, B and H, and these values get assigned to length, breadth and height. Therefore, the object B2 gets initialized as shown here. Length is 30, breadth is 50, height is 18 and wall gets the default value 0. While declaring objects, instead of passing values, I can also pass variables like this. Box B1 within parentheses x, y, z. But when you mention variables here, you should see to that these variables already have some values in them. Here I am getting input values for the variables x, y and z. So when object B1 is created, the values in x, y, z will be passed to the parameterized constructor. By getting input for the variables during runtime, you are able to dynamically initialize objects. This method of initializing objects is called dynamic initialization of objects. Look at the parameter of this constructor. Box ampersand A. Box is the class name and ampersand A is a reference object. When a constructor has this type of parameter, it is called copy constructor. In the same class, we can have more than one constructors. Here I have shown a parameterized constructor and a copy constructor. Therefore, within a class, you can define more than one constructors. This is because of the fact that constructor can be overloaded. You will learn about overloading in chapter 15. When the object B1 is created, the parameterized constructor gets executed. So, object B1 is initialized with values 40, 20 and 15. I am creating another object B2. Box B2 and within parenthesis B1. Here object B2 is created with the parameter B1. The parameter B1 is an already created object. This object B1 is passed to the copy constructor. That is, B1 is passed to object A. Since this object A is a reference object, the address of object B1 is passed to object A. This method of passing parameter is called call by reference method. In call by reference method, the address of the actual parameter is passed to the formal parameter. Now, both the objects A and B1 point to the same memory locations. That is, object A is an alias of B1. The body of the copy constructor looks like this. Length is equal to A dot length, breadth is equal to A dot breadth, height is equal to A dot height. Here in the right hand side, length, breadth and height are referred as a.length, a.breadth, a.height. Since a is an alias of b1 and a also points to the same length, breadth and height as of b1, a.length, a.breadth, a.height are nothing but the values of object b1. So object b2 is created by the execution of this copy constructor, and because of the copy constructor, object b2 also has the same values as of b1. Therefore, copy constructor is used when you want to create copies of an existing object. I will now consolidate all the points about constructor. What is a constructor? A constructor is a special member function to create and initialize an object. What are the characteristics of a constructor? Constructor has the same name as the class name. Constructor has no return type. Constructor is executed automatically when object is created. Constructor can be overloaded. Constructor can have parameters. Compiler generates a constructor in the absence of user-defined constructor. The meaning of the last point is, when the programmer does not define any constructor within the class, the compiler itself will generate a constructor. This constructor is also called as compiler-generated constructor. Constructor can be overloaded. Just now I explained this point in my examples. Constructor overloading means you can define more than one constructors within the same class. Constructors are of three types: non-parameterized constructor, parameterized constructor, and copy constructor. Non-parameterized constructor is also called default constructor or compiler generated constructor. There is another special member function which can be defined within a class. It is called destructor. This member function is called destructor. The destructor also has the same name as the class name but prefixed with tilde character. A destructor removes the memory of an object which was allocated by the constructor at the time of creating an object. That is, the objects created by the constructor are destroyed or removed by the destructor. When is the destructor executed? Destructor is executed automatically when object goes out of scope. Here in the main function, the objects b1 and b2 are created and initialized by the constructor, and when the program comes to an end, the destructor destroys these two objects. Destructor will remove the memory of an object in the reverse order. That is, first it will remove the object b2 and then object b1. Now let us see the points about destructor. A destructor removes the memory of an object which was allocated by the constructor at the time of creating an object. What are the characteristics of destructor? Destructor has the same name as the class name but prefixed with tilde character. Destructor has no return type. Destructor is executed automatically when object goes out of scope. Destructor cannot be overloaded. Destructor cannot have parameters. Compiler generates a destructor in the absence of user-defined destructor. Let me now compare constructor and destructor. Constructor is a special member function to create and initialize an object. Destructor removes the memory of an object which was allocated by the constructor at the time of creating an object. Constructor has the same name as the class name. Destructor also has the same name as the class name but prefixed with tilde character. Constructor has no return type. Destructor also has no return type. Constructor is executed automatically when object is created. Destructor is executed automatically when object goes out of scope. Constructor can be overloaded. Destructor cannot be overloaded. Overloading means there can be more than one constructor in the same class. Destructor cannot be overloaded, which means there can be only one destructor in a class. Constructor can have parameters. Destructor cannot have parameters. Compiler generates a constructor in the absence of user-defined constructor. Compiler generates a destructor in the absence of user-defined destructor. Constructor is executed automatically when object is created. We can also rephrase this point and write as constructor is executed automatically when object comes into scope. Here destructor is executed automatically when object goes out of scope. So in the same manner we can write here constructor is executed automatically when object comes into scope. What are the differences between constructor and destructor? Constructor has no return type. Destructor has no return type. This is not a difference, so I will remove it. Compiler generates a constructor in the absence of user-defined constructor. Compiler generates a destructor in the absence of user-defined destructor. This point also I will remove. So now we have remaining 4 points. These are the differences between constructor and destructor. That's all in this session. Thank you, children.